Okay, so if we have C6H14, and you're doing chlorination, right? So
Right.
Cl2 and light, we ended up with C6H13Cl. However, she said that we have 6 or 4.
4.
We have 4 constitutional isomers. What constitutional isomer stands for? What is one constitutional isomer?
One constitutional isomer. Well, I wrote some out that were.
Yeah. Remember, you have a constitutional isomer, I'm just changing the position of my Cl,
Yeah.
right? They have the same molecular formula, but the Cl is placed in a different carbon. So what I really need to do is find a skeleton that gives me 4 different positions for the Cl
Oh, I see, okay.
to be placed.
Uh-huh.
So if I do that, 1, 2, 3, 4, 5, 6, I would say, well, this guy here and this guy here, they're equivalents, right?
Mm-hmm.
This guy here and this guy here, they're equivalents. And this guy here and
Oh,
this
that's
guy
right.
there
Okay.
are equivalents.
Okay,
So
that's
with this skeleton, I only have 3 constitutionals. So I start placing the metal in the different positions to see what one gives me 4. So now let's grab this here and put it in there. So if I have 1, 2, 3, 4, 5, this guy here, then this and this would be equivalent. So it would be 1, 2, 3, I don't know, star, 4, and then this guy here could be my 5.
Yeah.
What
So
are
that
you
one
doing?
forms 5 instead of 4.
Yeah, this one forms 5. I don't want a 5, I only want a 4. So now let's do, instead of a metal there, let's do 1, 2, 3, 4, 5, 6. Okay, let's do this one. So on here, I have 1, 2, 3. Oh, 1, 2, 3. That doesn't give me at all.
And it's okay. Yeah. And then it's
So you end up with this structure.
And then we could have that structure there.
That forms 4 different
Yeah.
possibles.
See, it's just like playing
kind of
and
plug
checking.
Yeah,
Yeah.
I
So then I
forgot
say,
about
well,
that. Okay.
this is the same. These are the same. This guy and then this guy. So then I have my 4 different constitutional isomers there. Did you see that? How we figured out what one is the right skeleton? It's basically going over one by one. Oh, if I have in this position, or if I have this, if I have that, and then just checking what one will give you 4 different chlorines, halides.
Perfect. Okay. That's not bad. Okay.
Which structure is that on here? Like, what's the answer for 11?
C.
C.
Yeah. Okay, I think I got that one. Okay, so this one is going.
Let me just write C here. C also could give you, because C is CH3 and that, and then it's ethyl and ethyl.
Oh, okay, got it.
And then you have 1, 2, 3, and 4. So both can give you, that gives you 4, that gives you 4. Just need to check your answer, what one is
Okay.
the one that she wrote it in there.
So both work.
Both work, both give you 4 different constitutional isomers and
Typically, those are
coordination.
the same structure, but
Oh yeah, it's true. It's just grabbing this and flipping.
yep.
It's true. I didn't check it. Okay. It's true.
It's just looking at it in a different spatial
Yeah.
arrangement.
Yeah, I guess.
Okay, number 16. Which halogen is the best yield? So I think I figured it out. Okay, it was just, I want to make sure I have the right reason.
Why do we choose BR2 to be the R halide?
Because it will select that was my question. Is it because it goes to tertiary in this reaction?
Really selective to
Okay.
tertiary substrates.
And
So, sorry, just in order, because they said that, bromine's like our second best. What is our because we have bromine, then chlorine, then fluorine is the
Iodine.
worst. Iodine is
Iodine.
So,
Yeah. For this kind of theoretical situation, we always do chlorination or bromination.
okay.
Because an iodo is a really big molecule, it's really hard to fit in there. And bromination is really selective of tertiary substrates. So in the case, if we have this specific guy there and you say, what, if we were, instead of doing chlorination, we do bromination, we would say, this is the final product, like, I don't know, 80% of the time would be
Okay.
there. While the other one would be just minor products. While this
Okay.
guy here just make it here, 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 here in the same amount.
Okay.
The way
Because this is really selective.
Sorry, I was just gonna say, the way Sister Browning taught us the diatomics might help you also remember that order, because it's H, Noph, Colbri are all the diatomic elements, but if you do the Colbri, it's fluorine through chlorine, bromine, and iodine. Does that make sense?
Mhm.
Sense? So H, Noph, Colbri in the
Yeah.
periodic table.
Yeah.
Going down that
yeah.
H, Noph, Colbri, those are also the diatomics.
It's true. In the case of halogens, it asks there, it's just this guy's there.
Now, the reason I ask why the reason why I asked the order of the best addition, or the most, or the ones that we consider the best the best halogens to add, is because that iodine is in that list there, and is iodine not as selective as bromine?
It is not.
Okay.
And there we're looking for the one that gives us the best yield, so bromination would be the best one.
Okay, that's interesting. Yeah, I thought for some reason I thought iodine was like the most selective.
Most selective. Well, iodine is, I think, a better leaving group because it's so big. It's a better to leave. So when
it's a
you're
better
doing
leading
chemistry,
group, it's just not as good. It's not as selective.
it's not selective as Br.
Interesting.
So bromine, for some reason or another, is the one that's
Yeah, and I don't
selective.
know. I never heard the reason why this guy just likes tertiary substrates, because if you look to the whole molecule, we were thinking about this is an ethyl and an ethyl, so this is a huge chunk of carbon and hydrogens, and the bromine just goes in there because it just wants that position.
Which
and
is
this
surprising considering it's such a big molecule.
Yeah, and here you have so much space, it could just go there, but bromine just decide I'm gonna go to the tertiary substrate, doesn't matter what.
Okay.